This is an organization that centers around trying to solve the problems of physics phobia. So we use physics and other sciences to explain whatever is happening around us in our environment in a very simple way. So, but there are different subsidiaries. So we have first the science broadcast. I think that's the next one. Yeah. So we have the science broadcast. We also have the physics educational consulting, which is what is we are doing now. This is under this webinar series we are having. So this part involves helping physics teachers and students to grasp the concept of physics, but most importantly, to help the teachers on the best way to teach physics for both the understanding and also for passing examination, certificate examinations in particular. So there are so many other things under the physics educational consulting, but the one we are focusing on today is for the teachers, like we did in the 1 hour ago. We were discussing different techniques that I found useful for teaching physics, especially if you want the students to pass. And what we'll be looking at today and in this particular session will be common mistakes that students find when they are solving theory questions. And the other part of Stardust Discovery is the STEM career consulting or coaching. So if you are having challenges with deciding on a career path, especially if you are in the sciences, we also render services like that. And if you go to our YouTube channel, you will see contents related to all of these things. By the end of this, I will be showing you our handle so you will know how to exactly follow. But anyway, let's get into what we want to achieve today. So we are not able to exhaust everything we really have in mind for you today, because I mean, it's only 1 hour, but we'll have more of this. So we'll talk about that later. But for today, we are going to focus on common mistakes related to solving theory question in physics, especially for the West African School Certificate Examination, WASSCE. So we are going to use an example question to actually, look at these issues together. And feel free to ask any question. Stop me if you think you are not getting what I'm doing. So that's really what the goal for this particular session will be. And I'm going to use an example from that's June 2021. June 2021 past question. The theory parts, there are actually two parts of the theory section. The second part is where I'm taking this question from. It's actually question 10. So we are going to dive into that. So here is a question. I will read it out, but you also feel free to read, okay? This question says, define each of the following terms as it relates to converging lenses. And under that, we have the focal length and the optical center. The next question asks that you draw a ray diagram to illustrate how a converging lens is used to produce a visual image of an object. There are other questions here, like name the primary colors of light. There is also the second part of it saying, match each primary color to its corresponding complementary color. Then the last question is a calculation one. It says, a ray passes symmetrically through a glass prism of angle 60 degrees and refractive index of 1.5. Calculate the angle of incidence and the angle of deviation. All right. Okay, we are going to take them one after the other, and hopefully we'll find one or two traits about it. So let's start with the first question. Okay, so because this is talking about light, and in particular is mentioning converging lens, which is also called convex lens. I'm not going into all the background. I'm sure you already know what lenses are. So, and whenever you talk about lenses, it means you are talking about a particular property of light, which is refraction, because lenses refract, whereas mirrors would always refract. So mirrors will reflect, but the lenses will refract light. So we are talking about lenses here. And there are two major types of lenses. There is the converging lens and the diverging lens. So the converging lens, also known as the convex lens, is what we are asked about. I will be going back and forth so that we remind ourselves of the question while we try to answer it. So the first question is asking that you define the focal length with respect to a converging lens. So I thought I'd show this image of a typical converging lens. So, I mean, you know what the lens is here, the black, this stain there. I don't know if you can see my cursor, but this is the lens. Then how do you obtain the focal length? So it's easy to just define focal length, but I also just want to make sure that you understand what it means. So if you have a typical lens and you're asked to draw the ray path, so what will the light that will pass through that lens go through? So what is the light path for this lens? So this diagram here is allowing the light coming from a distant source, whatever object, to pass through this lens. And one of the laws, which I should be talking about very soon, about parallel light crossing through the lens, what happens is that they must converge at the focus. Again, I'm taking it that you already know what the lines of light means, and you also know what the focus is. So, but just to help us a bit, we have this middle of the lens, which you can take as your origin. We use that as a reference point, and there is a name for that. There is also the focus, which is where all parallel light, that when I mean parallel, that means they are parallel to the principal axis. So the principal axis is usually that line that crosses the center of the lens itself. So this reference point or origin is also called the optical center. So that principal axis line has to, be drawn if you want to demonstrate the ray of light. It helps you when you draw that. Then it's also useful that you draw the vertical line going through that origin so that you have both the vertical and the horizontal. Okay, just like if you're plotting graphs, so you have the X and the Y. So that helps you to know your point of origin clearly. So the first law when you're drawing ray paths is that if you are having light parallel to the principal axis, as they pass through the converging lens, they must meet at the focus point. And here, the F point is that focus point, okay? So why am I saying all of this? This is a basic information that you need for you to understand what a focal length is. Now, there are different ways that the ray of light can take. This is just one of them. But whatever means, the light ray tries to go, whatever it's doing, the distance between the optical center, which is this origin, and the focus point will give you the focal length every time. So if you are asked to define focal length, you will say that it is the distance between the center of the convex lens and the focal point. So all this explanation is just so that you understand why the answer is so. So in a typical exam hall, you will not be required to draw this diagram. You just respond by stating the correct answer. So, but one thing that is a general rule of thumb is that when you are asked to define something, whatever it is, you need to be accurate with definitions, because if you make a major mistake, so there are grammatical errors that can be huge, but there are simple errors like maybe you omitted is, for example, and that did not change the meaning of the sentence. That is different. But when the grammatical error now changes the meaning, that means what you defined isn't exactly what you were asked anymore. And that makes it tricky. So if a definition has, let's say, 2 marks, and you make mistake somewhere, let's say instead of saying the distance between the center of the lens and the focal point, maybe you said the distance between the principal axis and the focal point. You see, that's a major difference. So you cannot get full marks. In fact, you can't get any mark at all. When it comes to definition, there is no apportioning of half mark or some marks. No, it's like it's either you get it or you don't get it. So that's one thing with definition. We will see how this is a bit different for calculations. So, but for this question, a simple answer is enough, and you don't need diagram because you were not asked to. Except you want to flex your knowledge, that's also good. Right. So the other question is asking about the what is it called now? This center. They're asking about the optical center, that you should define the optical center. So again, I tried to show this diagram so that it will remind you about what you already know. So a typical ray diagram, you will always have the focal point, on both ends, remember, on both ends. And the optical center is this point at the middle of the lens. So it's usually at, that intersection between the principal axis and the vertical points of the lens. So, but in definition, what that point means is not just a reference point, but it is that point through which any ray of light that passes through it does not get deviated. So it does not get deviated. In fact, if at all there is refraction, that means it's refracting backwards in the same direction, in the opposite direction, but it's not going to bend. So as you can see from this image, the blue light is passing through that optical center. And so nothing happened compare, to the red one or the green. Notice that the green one, when they get to that vertical line, they bend, okay? But for this blue one, it goes through undeviated. So that phrase has to be there when you are defining the optical center. So I'm just going to explain it. You don't need the diagram. Define optical center is a point located at the geometric center of the lens through which rays of light pass through undeviated. So remember, you need to get your definitions right to get your full marks. So if the question has 2 marks or 3 marks, the whole 3 marks will be given to the correct answer. And any mistake means the whole 3 marks will be lost as well. Okay, so I will move on now to the next question. let's go back a bit to see what that question is. So the next one is asking that we draw a ray diagram to illustrate how a converging lens is used to produce a virtual image of an object. Virtual image, converging lens. So because of this, I'm going to give us three laws that guides trying to draw a ray diagram. And this is the law that light obeys when it's passing through a lens. So I mentioned one of them when I was explaining this particular diagram. So the first one is that rays of light that are coming from distant object but parallel to the principal axis, when they get to the lens, they will always converge at the focal point. So that is number one rule. The second rule is that any light or any ray of light passing through the optical center, just like in the second one, always pass through undeviated. So that's actually a law. So there is no way light will pass through the optical center and bend when it gets to the other side. So it does not happen. So that's the second one. All right. And the third one is that ray of light that is bent, when it gets to the lens, it will now become parallel to the principal axis. So it's just like the inverse of the first one. And I'm going to, I think we might be using that for this question that was asked. So we are going to draw a ray diagram to illustrate how a converging lens is used to produce a virtual image. So this is a typical example. So here you have the lens. So when you want to draw a ray diagram, you start off with drawing that shape, which is your lens. I also like to draw that vertical line. It's not showing on this one, but you should draw that vertical line. Then draw your principal axis, which is the horizontal line going through that optical center. Then decide what your focal length will be. You can measure it. And then make sure you map it out on both sides of the lens. So you should have your focal point on one end and also on the other end. Okay? So with that, you now decide where you want to insert your object. So for this particular example, here is the object, they called it object. They have gone further to label like the object distance, which is distance from the optical center to the object, and the image distance, which is distance from the optical center to the image. We are not using it right now, but it's a useful information to know when you are solving questions related to this. Also, the focal length is given, distance from the optical center to the focus, which can be from any end. It can also be from here to the optical center. It's supposed to be equal, remember. So whichever side you choose to start, it does not matter, but just have to follow these laws. So remember the first law, which says that if light is coming from an object and is parallel to the principal axis, it must pass through the focus on getting to the lens. So that's the first thing that happened here. So look at this object. So normally light from this object will pass through the lens. Can you see my arrow? So I'm using the arrow to show what's going on. I can also annotate this. So let me use annotation. So this is the object here. I don't like this color. Let me use black. Okay. So you have this object. Light will go from that object to the lens. So remember, the optical center, we pass through here. So I'm drawing it so that it's clear that this is the optical center. Can you see the screen and by annotation anyways? Let me know if you can see the annotation. So it's also important that you indicate the direction of the radiation or the ray of light using arrows. So you see this arrow shows that it's going this way. So that first law says that if the light ray is parallel to the principal axis, which is this one, remember, your objects and images usually would stand on the principal axis. That's your base. So that means that any light parallel to this one, when they get to the lens, they are going to get refracted. And that refraction will make them to pass through the focus. Remember, there is focus here. You also have that focus here. But because we are going this way, the one that it will pass through is this one. Okay? So this is the first law for ray of light. We just did that, okay? Now, the second one says that light passing through the optical center does not get deviated. So we can make light from that object pass through the optical center, just like you can see in the diagram. Now, it's also good to show your arrow that helps for the reader to know what you mean, okay? So this is the direction of light. So the second one is saying that this particular ray of light does not get deviated. So, but what happens when the object is between the focus and the optical center? What happens is that light gets no way to, like, there's no way for it to converge on this end. If you notice, these two rays are going their different directions. They are never going to meet. But if you look on this other end, there is some potential of meeting when you extrapolate the line. So that's what actually happens here. So the lines were extrapolated. This is that one that is, that passes through the optical center. You just extend it all the way up, until you are tired. Then get to this other one and extend it as well. So it's the same straight line. You use the ruler to do this. Don't mind that I'm using my hand. You do that until it begins to converge. And at one point, it's going to converge with this one. That point of intersection is where the image is formed. Now, because this image is behind the object and is on the same side of the object instead of being on the other side, that type of image is called a virtual image. It's not real, okay? So this is an example of how you get a virtual image. And this particular one is also magnified. See that it's bigger compared to the object. So it's going to look much bigger if you are looking at the screen. So the question that you are asked is to draw the ray diagram. So if you are able to draw the lens with proper label, I would advise you put this straight line. In fact, sometimes it's just the straight line that I use without even putting all of this one. But then you can write down that this is a converging lens. Then you have your object at the right position. You put the rays with their arrows. Without the arrows, you can lose some marks. So you put the rays with the arrows, then include the focal length, you can put that distance, label it. Then you can also include the object distance, which is from that optical center to the object. You label that. You also include the image distance. Now, make sure that your focal length or the focal point is on both ends. In fact, I also include the second one. So there is usually F and then 2F, because there are some ray paths that you do either at 2F or even beyond 2F. So, and 2F just means 2 times the distance of your focal length. Okay? So having them on both sides, you have your complete ray diagram. So if an examiner wants to mark this, it's not just going to mark everything once. So the marking is divided into different sections. So there are key points that the examiner would want to see. And those, those key points differ. Some years they could include something entirely different, and another year you may not see it. So the only thing I advise is that you be exhaustive of all the information, because you don't know how they will decide to mark. So do not say, oh, image distance is not important, object distance is not important, and then you leave it out. Who knows, maybe that particular year they will say it's important. So because you are not in the mind of the examiner, it's best that you do everything. So they could have half mark for proper ray with their arrows, or they could decide to give it 1 full mark. Then proper using dash lines to indicate that this is a virtual image, we have its own mark. Then proper labeling, that you are calling this object, calling this image, and also the distances in between. Also, we have its own another mark. So that is how you can get your full marks. So if you have this image, but you don't have the arrows, you may not get the full marks, even though you have drawn the correct thing. Okay? Interesting. So the last question is about light. So the question is about the colors of light. The primary colors are the red, the green, and the blue. I'm sure you know that. Simple, straightforward, okay? I think the one that gets tricky is the complementary colors. So I find that there are different color combinations. There is a red, green, blue, RGB model, and there are also other ones like the red, yellow, blue. So, but I think what you are expected to learn, or what they're using for, at least for your level, is the red, green, blue. So the red, green, blue has complementary colors this way. So this is just the primary colors. So the complementary colors would be the colors facing the particular primary color in this wheel. This is like a color wheel. So if this is the primary color, so blue, the complementary color is the one that is facing. Now, my question is, why are they primary colors and why are they complementary color? Because, I mean, if you don't understand what you are doing, then what's the point? So the primary colors, they are called primary colors because you can't get them by a combination of colors, right? You know how you can get brown when you combine blue and red, but you cannot get red when you combine something else. You can't get blue when you combine something else. The same thing as green. So these are colors that you cannot get by the combination of any other 2 colors. Now, the complementary colors are the color that when you add to the primary colors, they give you what they call the white color. So it's not necessarily white like white, but depending on the intensity of the colors, when they are being combined, you can actually produce white light. So that is why it's called complementary color. So the complementary color for blue is yellow. The one for red is cyan color. You can see them from this diagram. Then the one for green is magenta. So, and that answers this question actually. It's very, very straightforward. You don't need these diagrams. I'm just showing them to help you understand. So if for any reason, in your listing of primary colors, instead of having red, green, blue, you have red, yellow, blue. You have omitted one color, or color. So you probably, already that you won't get your full marks, right? So if they are assigning half marks for each of these, that means you will not get the full marks. You will lose half. But if the examiner decides to say, okay, any of them that is wrong, then award 0 for all of that question. That also means that if you fail anyone, you can get 0 for that whole thing, even though you got the other 2 correct. So I'm explaining it this way because these things, change from year to year. So I don't want to tell you from 1 year's experience. No, because I've been a physics teacher and I've also been an examiner for the WASSCE. So it's better that you understand the holistic picture and not just choose some of the method, because these things depends on what they decide to do for that year. Okay, so just keeping that in mind. All right, I will go to the next question, and I think that's the last, really, hopefully. Yeah. So this is the one that involves calculation, I believe. So let's go through that. A ray passes symmetrically through a glass prism of angle 60 degrees. I should scrap that degrees. And refractive index of 1.5. Calculate the angle of incidence. Have any of you gotten to this topic? I mean, it's still light, but this is refractive index. Have you handled this topic? I'm just waiting to get your response because it will determine how I should go. Okay, while we are waiting, I just have to put up this image to help just to understand what the question is talking about. So I find drawing very useful for solving physics questions, even if you were not asked. If you can replicate the question in a diagram, especially those ones that have diagrams, I don't think all of them need diagram, but there are some that do need diagram, and especially for calculations. I think it's helpful to visualize what the question is about. Sometimes you can see, some hints here and there just from the diagram. Okay, so this question is talking about a glass prism. There is a rectangular glass prism and there is a triangular glass prism. I know they didn't mention for sure, like whether it is rectangular or triangular, but from the parameters given to you, you will know what the question is referring to. So this is another trick to answering physics question. You need to be aware, be conversant with parameters related to certain type of topics, right? Because some parameters also can be similar to, maybe 2 topics or 3 topics. So you need to understand when that particular question is referring to a particular topic versus another topic. And one easy way to do that is to look at the information given. So here, they talked about the angle of prism. Now, I've never heard about angle of prism in rectangular prisms. So that automatically gives it away that this must be talking about triangular prism. Then the refractive index, well, that one you can get refractive index for rectangular prism as well. So I think what gives this one away is that angle of the prism. So we know that we are dealing with triangular prism here. So I'm showing a picture of that triangular prism. Now, the angle of the prism that was talked about is this angle. So that tells you the type of triangle as well, because you could be dealing with an angle, a triangle that has a 60-degree at all of the edges, which we call the equilateral triangle, right? We can also have a right angle triangle. However, this one says that we have a equilateral triangle. So this is going to be 60 degrees, the A here. So you start off by drawing this. I always prefer to draw this. So if you draw the triangle, label the A, you know that the refractive index is 1.5. Now, you can think about what the ray of light is doing by looking at the equation. So the equation says that the ray passes through symmetrically through the glass prism. And then it asked about the angle of incidence. So just think about the different equations that you know related to triangular prism, angle of incidence, and even this angle of prism. So what is that equation that connects these things? So that's one way to ask a physics equation. Like you need to know the different equations or formulas related to different topics. So when you also see parameters, it can spark to you what formula connects these parameters. That's another way to know the right formula or how to answer a question. So thinking about this, Snell's law comes to mind right away. So we have, first of all, the parameters given. I also like to write them out because it just gives you clarity. You know what you have and what you don't have. So for this particular equation, we are calling the angle of incidence the I and the angle of refraction R. So for you to obtain what you are looking for, you need to understand the relationship. So Snell's law, what is Snell's law? It states that the sine of the angle of incidence to the sine of the angle of refraction, that ratio gives you the refractive index. So that's Snell's law. So you write down that equation, which is here. Okay, so just looking at Snell's law, we already have the refractive index given as 1.5. What else do we have? Because we are asked to find the angle of incidence. So what else do we have that can help us to get the R, which is the angle of refraction? So that's the question that should be bugging your mind. You know, just looking at that equation, you know what you are given from the equations, then begin to think about the other things you don't have, especially when it's one-on-one, because if they just gave you the refraction angle, maybe it will be straightforward. But in this case, no. You were given instead the angle of the prism. But the good thing is that the angle of the prism, when you divide it by 2, you will get the refraction angle. Now, what if you don't know that? That becomes a challenge. So you see, you need to know the different equations and the relationships between one parameter and another. So that is what we just did. When you divide that by 2, you get the angle of refraction. So now that you have only one unknown, it's easy to solve this question because you can't deal with two unknowns when you just have one equation, okay? So substitute whatever you have into that formula. So that's what we've just done. When you substitute that, you solve for sine 30, which will give you 0.5, multiply out. You have to cross multiply here, okay? And then that gives you 0.75. So what you have now is sine I equal to 0.75. So what do you do to get your I? You do the sine inverse of 0.75, and that should give you an angle in degrees. So that angle is your angle of incidence. Now, let me explain a little bit of how the WASSCE examiner expects you to answer this question. So first, you identify the equation that is correct. So you have 1 mark for the equation that is correct. So this Snell's law is one of that, is the equation of this equation. So you will get that 1 mark. Now, you have another 1 mark for knowing that A divided by 2 will give you R. So that's another mark right there. Then you also get mark for proper substitution, which is why I always like, it's good to show your workings. Remember, it's theory, it's not objective. So you cannot say, oh, the examiner understands how you went from here all the way to here. No, you have to show your workings. So there is a mark for actual substitution, okay? Then final answer has 1 mark. But if you don't get the units right, you can also miss half a mark from that. So the unit is what defines the quantity. If you don't put units, you may be talking about another quantity. That's what it means. So it's very crucial for sciences in general that you put the unit of every quantity. So in this case, you see now I'm leaving it in 4 decimal places. This is because the WASSCE standard is 3 or 4. And even if you want to round it up, it's always advised that you give out these 4 values first, or these 4 decimal places 1. So no matter what you solve, when you get to the end of your answer, leave it in 4 decimal places. Even if they ask that you round it off to, let's say, 2 decimal places or 2 significant figures, you can do that as another layer of the answer, like what I just did now. So you can just add that again and write to 2 significant figure, or in this case, to 1 decimal places. So in this case, I'm rounding up to 1 decimal place. So you get full marks, for the answer when you have it in the right decimal places and the unit is also included. If you are asked specifically to round the answer to maybe some significant figures or decimal places, that means there will be an additional mark for that rounding. So which is also why it's important that you separate them. So give the actual value in 4 or 3 decimal places before you now give the rounded value. Okay? Now, the diagram is not important, but it's good to show that you know what you are doing. For this question, you are not asked to draw, but it's always advised that you do that if possible. Okay? Before I move on, I think I'm getting to the very last one. I think the last one is the minimum deviation angle. But I just want to make sure that I'm not losing out anyone. So are you all following? Is this clear so far? And do you have any question? All right. All right. Cool. Okay, so Getting to the last one, the minimum deviation. Let's call it DM here. So I think we should go back to that diagram to understand this idea of the minimum deviation. So in this diagram, remember I only just showed this angle and the refractive index for the first one, but actually something is going on here. So the ray of light that is passing through this triangular prism can go through different ways. Like, depending on the refractive index of that prism, it can behave different ways. But also depending on what we call the angle of incidence, okay? So when you're drawing ray path for a triangular glass, I always advise that you start with your normal, which is this perpendicular line to the first surface, which is the interface where that angle of where the incident light will meet the prism. That surface, is the first contact. So this particular place is usually where most people use. So draw your normal, let it be perpendicular to this. I always use protractor to do this. Then the angle of incidence is that angle between the normal and the incident light. So you make sure you are getting that angle correctly. Let's name it whatever, right? Theta, they called it here, but I think I said I. Now, this angle can take any value. It could be 15 degrees, it could be 60, okay? But whatever it is fine. And then if that ray of light gets to the prism, it will be refracted. And it will change the course of its path due to refraction. Refraction actually means bending. So it just say it to be bent. So now it bends, continue all the way to another medium. So this bending is also caused because of the difference in medium. So, it's moving from air to glass in this case. Here it's moving from glass to air. So the difference in medium causes the bending. So at this point, because it's moving to a much lighter media, air is light compared to glass. So it's bending towards this direction as a result. So that's the normal ray diagram part for a triangular prism. But what I want to emphasize here is that there is a certain phenomenon that causes the angle of incidence to become equal to the angle here. Don't know if you can see this angle. When it's finally emerging out of the prism again, we call this the emergence ray. So this is the incidence ray, this is the refracted ray, and this is the emergence ray. So at this emerging part, you also need to draw the normal perpendicular to that interface so that the angle between the normal and the emergence ray is your angle of emergence. So there is a situation whereby the angle of incidence is equal to the angle of emergence. Now, what that happens, or rather what that causes is that, what happens there is that there is minimum deviation. The minimum deviation, which you can estimate by measuring that angle, this angle, actually you get that by extrapolating the incident ray all the way out so that you can measure the angle between that and the emergence ray. That gives you the minimum deviation. So this angle is what we are asked to calculate in this question. So I don't know if that makes sense, but just to show you in principle what we are about to calculate, okay? So let's get to the equation proper. Now, in order to do that, remember Snell's law is actually sine I over sine R. However, when minimum deviation is happening, when you are at the minimum deviation situation, that angle of incidence can also be obtained using this equation. So the minimum deviation plus the angle of the prism, divide them by 2. That gives you the angle of incidence. While the angle of refraction is gotten by half of the prism angle. Remember, we did this for the last question, all right? So this becomes your new equation for solving that particular issue, okay? So still Snell's law is still Snell's law. It's just that it's a bit transformed. And then if you look at this equation now and think about what we are given, you see that we have the refractive index, we have the A, which is also here, but we do not have the minimum deviation, and that is what we are asked to find. So we are good because we have the A. So with this, we can just put in our values and solve the equation. All right. So we want to find the minimum deviation. So what you do is to substitute all you have first of all. So you have the refractive index 1.5, you have the angle of the prism 60, you put them all in, then start with the easiest one, right? So you can divide this to give you 30, and the sine of 30 gives you 0.5. And you are left with this. You still do not know what to do with this, okay? But when you rearrange, you'll find that cross multiplying, we'll have 0.5 multiplying 1.5. And that gives you 0.75, actually. Now you are beginning to, get down to it. So because all of these are all under the sine, they are all going to form that angle. You can't just separate them. You need to take away the sine first. So that means if you find the sine inverse of 0.75, that will release whatever is here. So we have that already even from the last question as 48.5904 degrees. So when you are using a value or an answer to continue to another question, it's always advisable that you use the 3 decimal places result or 4 decimal places result. Do not use the rounded one. See that in this case, we have somehow done this before, but what I'm using here is the one with the 4 decimal places. So you do not want to use 48.6. That's a rounded figure, okay? So yeah, so you see, you can now play around with this. We've taken away the sign. It's a free word now. So at this point, you can cross multiply again so that this gives you 97.1808. And you can move over the 60 to the other end. And that should give you the minimum deviation. So again, you give your values in 4 decimal places first before you give the rounded one. And the units will always be important. And I think this is the end of it. So remember, the whole idea is not to solve these questions for you. Instead, I'm just using the question to draw your attention to points and hints for answering physics questions, especially what the examiner expects of you. So just like I mentioned the other time, your formula is so important because if you do not get the formula right, you can mess up the whole thing. And that's why it's theory, because you are showing all workings. So you do not jump steps when you are answering theory questions. Show all your workings. You see the way I have shown all the workings? After stating the formula, I substitute every, values that I have, then take it from there, break it down, try to solve until I get to the unknown, making it the subject of the formula. So final answer, which we have its own mark before the rounded answer, and the units we also have its own mark. So you do not miss out on the right unit, because the unit can change the value of that quantity. Okay, I'm going to stop here, and then I will look through the charts if you have any question, and let me know, what do you think? Did this solve any of your problems? Did it address any question you had? And I will just wrap this up by saying that you can. Good. Thanks for that. Yeah. You can actually, find other questions that I've solved. If you check out Discovery Stardust, it's our YouTube channel. We also have some of them on TikTok. And then Facebook is usually where we post about any event we have. So you can also follow us there to know, and subscribe so that when we, post videos, you will get to know about it. And you can use this email address to ask any question you have or reach out if you need to.